This video is about adding and subtracting polynomials, and the goal is I can add and subtract polynomials. First, let's start with some review exercises. So the directions state solve each equation. So for number 1, looking at this equation on the left side of the equal sign, I need to distribute the -2. So first I have 5a, so I'm going to rewrite that. -2 times 4a is a -8a. -2 times 5 is -10 equals 7a. Now I'm going to combine some like terms. So I'm looking at that left side of the equal sign. I have 5a and a -8a, and that becomes -3a. Minus 10 is equal to 7a. Next, I'm going to move all the a's onto the right side of the equation. So I'm going to add 3a to both sides of the equal sign. So -3a plus 3a is 0. So now I have -10 is equal to 10a. And I'm going to continue solving for a by dividing by 10 on both sides. Then I have a is equal to a -1. So that's the answer for our first equation. Now let's take a look at number 2. So first thing I'm going to do with this equation is I'm going to combine like terms on the left side of my equal sign. So I have a -1d and a -3d, which becomes -4d, plus 12 is equal to 5d minus 6. Next, I'm going to move all of the d's onto one side of the equal sign and all the numbers onto the other side of the equal sign. So first, I'm going to subtract 5d on both sides of the equal sign. -4d minus 5d is a -9d. Plus 12 is equal to 5d minus 5d cancels, that makes 0, is equal to -6. Next step is I'm going to subtract 12 on both sides of the equal sign. Now I have -9d is equal to 12 minus 12 is 0, so that canceled. And then -6 minus 12 is a -18. I'm going to continue solving for my d variable by dividing by a -9 on both sides of the equal sign. And now I have d is equal to a +2. Now let's get into adding and subtracting polynomials. First, let's start with some vocabulary. First of all, what is a monomial? And a monomial is a real number, a variable, or a product of a real number and variables with whole number exponents. So let me give you some examples so that you understand what a monomial is. For example, it could be a real number, like the number 18. It could be a variable, like, let's say, x. It could be a product of a real number and variables. So let's say we have -4 x squared y. So those are some examples of what a monomial could look like. Now let's talk about a polynomial. And a polynomial is a sum or difference of 2 or more monomials. So an example of this would be 3x to the fourth plus 5x squared minus 7x plus 1. Now each monomial is separated by a plus or minus sign. So we have 1, 2, 3, 4 monomials in a polynomial for this example. When you're writing your answers, we're going to ask that you write your answer in standard form. So standard form of a polynomial is written with the degrees of its monomials decreasing from left to right. First, let's talk about what a degree of a monomial is. And that's the sum of the exponents of the variables. So let me show you an example of what a degree of a monomial is, and then we'll get back to the standard form of a polynomial. So for example, if we have 5x, we have one variable, and the variable has an exponent of 1. So therefore, the degree would be 1 for this example. Now let's try another one. What if we have 6x to the third y squared? Here, if I add up all the exponents from the variables, we have 3 and 2, which adds up to 5. So the degree would be 5. Let's do one more example. And let's say we have the monomial of 4. For this one, we don't have any variables, so therefore the degree would be considered as 0. So now when we go back to looking at standard form of a polynomial, that is when the monomials, their degrees are decreasing from left to right. So for example, our example right here that we wrote, 3x to the fourth plus 5x squared minus 7x plus 1 would be considered in standard form because this has a degree of 4, 2, we have an invisible 1 right here, and then 0. So that would be considered written in standard form. Let's try some example problems. The directions state add or subtract each polynomial, then write your answer in standard form. So looking at number 1, first all I'm doing is adding these two polynomials together, which is just like combining like terms. So here I have a 3x squared, a 4x squared. So if I combine those, 3x squared plus 4x squared is 7x squared. Next I have a positive 6x and a positive 5x. So 6x plus 5x is 11x. So I'm going to write plus 11x. And then I have a negative 1 and a positive 9. Negative 1 plus 9 is 8. Since it's a positive 8, I'm going to write plus 8. And our answer is written in standard form because the degree goes 2, 1, and then 0. Number 2. Again, I notice that we are adding. So this plus sign right here. So I'm just going to combine like terms. I'm going to start with the highest degree that I have though. And I notice that that is our y cubed. So I have a negative 6y cubed. Remember to always take the sign that's in front of the variables that you're looking at. So I'm going to take this minus sign or that negative sign with me. And I have 2y cubed. So a negative 6 plus 2y cubed is going to be a negative 4y cubed. Now I'm going to look for my next biggest degree. which is this negative 4y squared. There's nothing else that has a y squared in it, so I'm going to write that next. There's nothing combined with it. Negative 4y squared. And the next highest degree is my y variable, so I have a negative 5y, so minus 5y. And then last I have my numbers. I have 2 and a negative 1, and 2 minus 1 is a positive 1, so I'm going to write plus 1. Now number 3, for this one I'm subtracting. Now these ones work a little bit differently. What I like to do is I like to pretend that there is an invisible 1 right here. So I like to think of that as a negative 1. And I distribute this negative 1 to everything in the parentheses to the right. So first I'm going to do is I'm going to rewrite my expression in the left set of parentheses. So I have negative 5x cubed plus x. Now I'm going to distribute that negative 1. Then I won't have to worry about that subtraction sign, and I can just combine like terms like I did for the addition. So negative 1 times a negative 9 is a positive 9x cubed. Negative 1 times a positive 2 is a negative 2x squared. And lastly, I have a negative 1 times 4, which is a negative 4, and then x. Now I'm going to combine like terms like I normally do. I'm going to start with the biggest degree, which I know says the x cubed. So negative 5x cubed plus 9x cubed is 4x cubed. My next biggest degree is my negative 2x squared, so I have minus 2x squared. And then last I have my x terms, negative 4x and positive 1x, and that makes a negative 3x. So there's my polynomial written in standard form. The last one is number 4. Again, I see that I'm subtracting, so that I don't have to worry about subtracting. I'm going to distribute the negative 1 first, and then I'm going to combine like terms. So first I'm going to rewrite the first polynomial, so 2x minus 3 plus 7x squared. Negative 1 times 3 is a negative 3. Negative 1 times a negative 9x squared is a positive 9x squared. And negative 1 times a negative 2x is a positive 2x. And now I'm going to combine like terms. So first I'm going to start with my highest degree, which is x squared. So positive 7x squared and plus 9x squared is 16x squared. Then I have my x terms. I have 2x plus 2x, which is 4x. So it's a positive 4x, so plus 4x. And then I have a negative 3 and a negative 3. Negative 3 minus 3 is a negative 6, so minus 6. And my answer is written in standard form.